What if the most dangerous weapon in the Strait of Hormuz was never the missile? What if the weapon that could stop a quarter of the world's seaborne oil trade was something almost invisible? No explosion, no aircraft overhead, no dramatic launch from a coastal battery, just a small object resting somewhere beneath the water. For years, Iran's most powerful card in the Strait of Hormuz has been the sea mine. Cheap to deploy, difficult to detect, and potentially catastrophic to remove. But now the United States is changing the equation. Not with a bigger warship. Not with a larger missile. Sonar, autonomous underwater vehicles, helicopters, and robotic systems designed to find the invisible threat before a sailor ever has to touch it. And that creates the central mystery of Hormuz. Can a weapon designed to make an entire waterway too dangerous to enter still work when technology makes the waterway visible? To understand why that matters, the Strait of Hormuz is narrow. On a satellite image, it looks almost insignificant compared with the enormous oceans surrounding it. But this thin blue corridor connects the Persian Gulf to the wider world. Tankers move through it carrying energy that powers factories, vehicles, homes, and entire economies thousands of miles away. That means Iran does not need to defeat the United States Navy to create a global crisis. It only needs to make shipping uncertain. A missile has to hit. A mine only has to exist. That difference changes everything. Imagine an anchor captain approaching the strait. The ship may be hundreds of meters long. The cargo may be worth millions of dollars. But the danger beneath the hull could be smaller than a car. The crew cannot see it. The radar cannot simply reveal it. And even if intelligence suggests mines are present, nobody knows exactly where they are. That uncertainty becomes the weapon. Because shipping companies do not need proof that a mine will strike. They only need to believe that one might. Then the calculations begin. Insurance premiums rise. Routes are delayed. Crews hesitate. Cargo waits in port. Iran does not need to physically close the Strait of Hormuz. It only needs to make the world believe that passing through it is no longer worth the risk. But here's the contradiction. The weapon is cheap. The response can be enormously expensive. For decades, mine warfare forced navies into a dangerous exchange. A relatively inexpensive mine could threaten an extremely expensive warship. The defender had to search. The attacker only had to hide. And searching for something you cannot see is fundamentally different from destroying something you can. That was the problem facing the United States when Iranian forces began using mines as part of their strategy around the strait. The question was not simply how to destroy individual mines. The real question was much harder. How do you convince the entire maritime industry that the water is safe again? Because clearing one mine is not enough. You must create confidence. And confidence requires something more than firepower. It requires information. That is where the American response becomes strategically interesting. The United States began shifting the mission away from the old image of a mine hunter slowly moving through dangerous water. Instead, the battlefield became layered. Above the surface, helicopters search. Below it, sonar systems map. Underwater vehicles investigate. And human operators remain farther away from the explosion. The weapon is no longer the individual machine. That is the first major revelation of Hormuz. The United States is not trying to beat the mine with a bigger mine minus clearing ship. It is trying to make the mine itself strategically irrelevant. But that creates another problem. Finding a mine is not the same as proving the water is safe. And this distinction is where modern mine warfare becomes far more complicated than it appears. An airborne laser detection system can search the surface in shallow water. Sonar can examine the seabed. Unmanned underwater vehicles can move into areas where sending a crewed vessel would be unnecessarily dangerous. But none of these systems sees the entire battlefield alone. Each sensor creates another piece of the picture. The helicopter sees one layer. The sonar sees another. The underwater vehicle adds another. The robotic neutralizer then acts on the information. The result is a kill web. Not one machine. Detect, classify, confirm, neutralize. The mind is no longer waiting in darkness against a blind opponent. It is being hunted by a system designed to turn uncertainty into information. And that is where the strategic balance begins to shift. Because the mind's greatest advantage was never its explosive power. Its greatest advantage was uncertainty. Remove the uncertainty, and the mind loses much of its strategic value. But the story becomes even more complicated when you look at the Navy's traditional approach. For decades, specialized mine warfare vessels were designed around the unique dangers of the mission. Their construction reflected a simple reality. When you are hunting mines, the ship itself becomes part of the problem. Magnetic signatures matter. Acoustic signatures matter. Distance matters. Survival matters. But the modern approach increasingly moves the human away from the mine and puts sensors and machines and the danger's own instead. That is more than a technological upgrade. It is a change in philosophy. The Navy is gradually moving from asking, how do we build a ship that can survive mine warfare, to how do we prevent a human crew from having to enter the minefield at all? And this changes the role of the warship itself. The ship becomes a command node. The helicopter becomes a sensor. The underwater drone becomes a scout. The robot becomes the operator's hand. The mine is still there, but the human no longer has to be. And then another threat enters the picture. Because Iran's asymmetric strategy in the region has never depended on one weapon. It depends on forcing the opponent to spend more than the attacker. Cheap mines, cheap drones, fast attack craft, low-cost systems designed to threaten high-value platforms. The logic is simple. If Iran can force the United States to fire $1 million interceptor at a cheap drone, the exchange eventually becomes unsustainable. But the United States is beginning to experiment with a different answer. Directed energy. On a carrier deck, a laser system is tested against drones. The significance is not simply that a laser can destroy an aircraft. The deeper question is what happens when the cost of defending against a cheap attack falls dramatically. A missile has a finite magazine. A laser depends primarily on power and cooling. A missile must be manufactured. A laser shot is generated at the moment of engagement. The technology is still developing. The system is not a magic weapon. But strategically, the direction is unmistakable. And that brings us to the contradiction at the heart of the Strait of Hormuz. Iran built its strategy around making American power expensive. The United States is responding by making the defense increasingly scalable. But if that is the real battle, then the mines and drones are only the surface. Because the deeper fight is not over who can destroy them or weapons. It is over who can force the other side to spend more resources simply to maintain access. And once you see that, the Strait of Hormuz looks very different. It becomes an economic battlefield, a technological battlefield, and eventually, a test of whether modern military systems can defeat an enemy not by destroying everything it owns, but by making its cheapest weapons no longer worth using. Everyone thinks the battle for the Strait of Hormuz is about mines, drones, ships, and missiles. But the real battle is about something far more important: cost. And more specifically, who controls the cost of war. For decades, Iran understood something that many technologically superior militaries sometimes forget. You do not have to match an opponent's strength. You only have to find the point where that strength becomes expensive. A mine does exactly that. A cheap object can force an expensive ship to slow down. A drone can force $1 billion platform to activate defensive systems. A swarm can consume interceptors. A threat can consume time, and uncertainty can consume an entire economy. That is the invisible battlefield of Hormuz. Not the seafloor, the balance sheet. The first layer is military. The United States can bring enormous naval power into the region. But raw firepower does not automatically reopen a waterway. You can destroy a coastal battery. You can strike a missile launcher. You can sink a fast attack craft, and still leave the sea psychologically closed. Because the shipping industry does not operate on military confidence alone. That means the real victory condition is not simply clearing mines. It is restoring trust. An anchor captain must believe the route is safe. An insurer must believe the probability of loss is manageable. A shipping company must believe the economic reward justifies the danger. And governments must believe the waterway can remain open tomorrow, not just today. This is why the American mine clearing architecture matters. The system is designed not merely to destroy mines, but to create a chain of evidence. Sensors detect. Operators classify. Then the water is checked again. And measurable problems can be managed. That is the deeper strategic revolution. The mine has not disappeared. The uncertainty surrounding it has. At least potentially. But technology creates its own vulnerability. Every new system depends on another system. Sensors require power. Drones require communications. Robotic vehicles require control links. Helicopters require maintenance. Command networks require data. And all of them depend on people. This means the future of mine warfare may become a battle over the network itself. If Iran cannot defeat the mine-clearing robot, perhaps it attacks the communications architecture supporting it. If it cannot hide the mine, perhaps it overwhelms the sensors. If it cannot close the waterway physically, perhaps it creates enough attacks elsewhere to stretch the defensive network. That changes the question again. Can the United States build a system that is not only technologically superior, but resilient enough to survive under continuous attack? The same logic applies to directed energy. A laser can offer an extraordinary economic advantage against certain threats. But the laser still needs energy. It needs cooling. It needs a functioning platform. It needs clear enough conditions to operate effectively. So the future battlefield is not simply about who has the best weapon. It is about who can keep the entire system functioning when the enemy attacks the system itself. That is why the Strait of Hormuz matters, far beyond the Gulf. Because the consequences move outward. First comes the military problem. Then the shipping problem. Then the energy problem. Then the economic problem. The geopolitical problem. A disruption in Hormuz does not remain in Hormuz. Oil prices move. Insurance markets react. Refineries adjust. Governments begin searching for alternative supplies. Allies demand protection. Rivals calculate opportunities. A narrow maritime corridor can therefore become a pressure point in the global economy. And this is where Iran's strategy contains another contradiction. The more aggressively Tehran threatens the strait, the more countries that depend on the strait have an incentive to cooperate against it. A weapon designed to isolate the enemy can sometimes isolate the attacker instead. China needs energy. South Korea needs energy. Japan needs energy. European economies need stable global markets. Gulf producers need exports. The United States needs freedom of navigation. These interests are not identical, but they overlap. And when they overlap, the strategic environment around Iran becomes more complicated. The Strait of Hormuz therefore becomes a test of whether asymmetric warfare can remain effective once the opponent adapts. Iran's advantage was surprise. Then it was uncertainty. Then it was cost. Now the United States is attempting to remove all three. The mine-clearing network reduces uncertainty. Unmanned systems reduce human exposure. Directed energy may reduce defensive cost. And persistent surveillance reduces surprise. But here's the problem. Every time one side closes a vulnerability, the other side searches for a new one. That is how modern warfare evolves. Not as a straight line, as an endless contest between adaptation and counter-adaptation. A minefield becomes a sensor problem. The sensor problem becomes a communications problem. The communications problem becomes an electronic warfare problem. The electronic warfare problem becomes an industrial problem. And, suddenly, a battle that began beneath the water is being decided by factories, power grids, software, and supply chains. That is the real battlefield. The United States may be able to clear a path through the Strait of Hormuz, but maintaining that path could require an entire ecosystem of technology and logistics. Iran understands this, which means the next phase may not look like traditional naval warfare at all. There may be fewer dramatic fleet engagements. The contest could become a continuous struggle over sensors, drones, communications, and economic endurance. The side that wins may not be the side that destroys the most weapons. It may be the side that forces the other to spend more resources, maintaining the ability to fight. And that brings us back to the water. Imagine the Strait of Hormuz at night. 8 anchor moves slowly through the darkness. Above it, a helicopter scans the surface. Far below, an autonomous vehicle maps the seabed. Somewhere in a command center, operators watch data streams converge into a single picture. The ship continues forward. No explosion, no missile launch, no dramatic battle. And that silence may be the most important sign of all. Because the success of mine warfare technology is measured by what does not happen. The ship that was never hit. The sailor who never entered the minefield. The drone that never reached the target. The missile that was never fired. This is the paradox of modern military power. The most effective weapon may be the one that changes the enemy's calculation before the weapon is ever used. The Strait of Hormuz was once a place where a cheap mine could create an expensive crisis. Now it is becoming a laboratory for a different model of warfare. Sensors against uncertainty. Robots against exposure. Networks against asymmetry. But there is one final question. If Iran's cheapest weapons can be defeated by America's most advanced systems, has the United States actually solved the problem? Or has it simply moved the battlefield to a new level where the next contest will be fought over the networks, power supplies, communications, and industrial systems that make those advanced defenses possible? The question is no longer whether the United States can clear a minefield. The real question is whether it can maintain control of the entire system that keeps the waterway open. Because in the next war, the side that controls the sea may not be the side with the strongest fleet. It may be the side that can keep its sensors alive, its networks connected, and its defenses affordable longer than the enemy can sustain the attack. So what do you think? Will future naval wars be decided by the most powerful weapons or by the side with the most resilient system?